Hello. So today we're going to solve rational equations. So we're going to solve equations that have x in the denominator. Um, Up until this point, we've been simplifying rational expressions. So two or more rational functions being added, subtracted, divided, multiplied together, but they weren't equal to anything. So we couldn't solve for x. But now we're going to do that same stuff, but we're going to be equal to something so we can solve for x. This is actually a little bit easier, especially when we have addition and subtraction involved, because we are equal to something. There are some tricks we can do to get rid of the fact that these are even fractions. So to make it so the fractions go away and we are working with something that has no denominator and we can just solve for x. Okay, you can get the real solutions from the graph. That's fine. You can do that. You can have an idea of what that answer is going to be. You can use that to check yourself. But on a quiz, if you just give me the answer, x equals a number, you will get a 6 out of 10. I need to see algebraic support. I need you to show me that you can do this method or another method to algebraically support this. So I'm going to show you my favorite way to do this, the one that I think is the easiest. But if you watch a Khan Academy video or you get help in math lab or something and you learn a different method, that's fine. You just need to make sure you're showing me algebraic support. So my method, you're going to look at all your fractions. Okay, so here we actually have two fractions. I know it only looks like we have one, but if you have something that's just a regular number, it has no denominator, it technically has a denominator of 1. We just don't write it. Okay, so I'm working with two fractions here. I want to find my least common denominator. Let's just look at all my denominators. I've got 2x minus 1, and I've got 1. Okay, if I multiply those together, I'm going to get 2x minus 1. So that is my LCD, 2x minus 1. Now, rather than getting everything to have a common denominator, instead, we're just going to multiply every term by that common denominator. So by whatever that value is. Because we're now equal to something, as long as we do the same thing on both sides of equals, we do it to every term on both sides, it's not illegal algebra. It's allowed. So I'm going to multiply this fraction by 2x minus 1 just on the top. And I'm going to multiply this fraction by 2x minus 1 just on the top. It's okay that I do that as long as I do it on both sides of equals. Then I don't have to do it on the top and the bottom. Okay. On the left side here, that means I'm just going to distribute. Oh, getting ahead of myself. Sorry. So on the left side here, I've got 8 times 2x minus 1 over 2x minus 1. And on the right side, I've got 2 times 2x minus 1 over 1. On the left, we can see we have 2x minus 1 on the top and the bottom, so that cancels. On the right, we don't have to write that over 1 anymore. So I've just got 2 times 2x minus 1. Okay, I can distribute that 2 or divide both sides by 2. Either way will work. And then just continue to solve for x. And we get x is 2.5. Now, just like with radicals, that could be extraneous, could be real. We need to plug it into the equation and see if it works, or my favorite graph. So I want to know when 8 over 2x minus 1 is equal to 2, and it is when x is 2.5. So that's a real solution. Oops. Okay, let's do another one. All right, now we've got three fractions. Same thing. Again, I can think of this as 1 over 1. So if I look at all my denominators, I've got 1, x, and 3. If I multiply all those together, I get 3x. So what I want to do here is multiply every one of my fractions by 3x, every one of my terms by 3x. So I've got 1 times 3x over 1. I've got 6 times 3x over x, and that's equal to x times 3x over 3. Okay, that first one just simplifies to 3x. This next one, I've got 18x over x. Those x's cancel. And I've got 3x squared over 3. Those 3's cancel. So I've got 3x plus 18 equals x squared. My fractions are gone. But to solve for x here, I'm going to have to factor or use the quadratic formula because I have x squared and x. So I can't just get x by itself. I like to keep x squared positive. So I'm going to move the 3x and the 18 to the other side, and you can either factor or use the quadratic formula, whatever your preference is. But this is what it will factor to. So my solutions are 6 or -3. Okay? We can plug them in to see if they work, or we can head to the graph to check. So I had 1 plus 6 over x, and I want to know when that's equal to x over 3. I see two solutions, -3 and 6. They are both real solutions. Okay, let's do another one. All right. Once again, 3 fractions. Looking at my denominators, I've got 1, I've got x, I've got 2. Multiply those together, I get 2x. Okay, so I'm going to multiply every term by 2x. Again, we only have to do it on the top for this method because we do have an equal sign. As long as we do it to every term on both sides of equals, we're fine. Okay, so that simplifies to 6x squared over 1. We don't have to write the 1. This simplifies to 8. The x's cancel. And here the 2's cancel, 13x. Okay, we're going to have to factor or use the quadratic formula. I like to keep the x squared term positive. I think it's easier to factor. So I moved everything over to the left. Okay, this one's a little bit more challenging. AC method. 6 times -8 is -48. And we need factors of 48 that are going to add up to 13. So you can figure it out in your head, great. If it makes more sense for you to look at a factor pair list, you can. Okay, so it needs to multiply to -48, but add up to +13. So that's going to have to be -3 and +16. Those will multiply to -48, but those will add up to 13. So I'm going to rewrite this 6x squared minus 3x plus 16x minus 8. Take out greatest common factor. So I get 3x plus 8 times 2x minus 1 equals 0. Solving for x then, for each of those, 3x equals -8, x equals -8 over 3. X equals 1/2. Let's check the graph. So we had 3x on the left, on the right, and it looks like 1/2 and -2 2/3 or -8/3. Those are both real. Excellent. Both real solutions.